If you're looking at the worksheet that you have labeled Electron Configuration Ion Charge, we are going to start by going through the first example on that sheet. But before we do that, let's just talk a little bit about what oxidation number is. So an oxidation number just represents the charge of the ion that is formed by a particular element. Because elements consistently gain or lose the same number of electrons to form an ion, we just assign a number to that number of electrons that's being gained or lost. And that is what the oxidation number is. It just represents the charge that that atom typically has when it becomes its ion form. So now that we've talked about that, let's go through the first row of the table on your worksheet, and the element there is sulfur. So the first column, you need to determine what the group number for sulfur is, and you do that by looking at your periodic table and then just counting across how many columns sulfur is to the right. And if you count all the way across, you'll see that sulfur is in group or column 16. So go ahead and record that sulfur is in group 16 of the periodic table. And then to determine the period number, you start at the top of the periodic table and count down how many rows sulfur is down. So counting 1, 2, 3 rows down, so sulfur is in period 3. Once you do that, it should be easy to determine the electron configuration based on the periodic table. As we talked about in class last Friday, to determine electron configuration, you just read the periodic table from left to right, starting at the top left-hand corner with hydrogen, and following what row and what block of elements you are in. So to start our electron configuration, we're starting in row 1. Sulfur is atomic number 16, meaning that its neutral state will have 16 protons and also 16 electrons. So we can write that electron configuration knowing that we are going to need 16 total electrons in our electron configuration at the end. So we're going to start with 1s2, and we move down to the second row, and we're in the s block, so 2s2. Then we're going over into the p block, so 2p6. Going down to the third row, we have 3s2. And then going into the p block of the third row of the periodic table, we have 3p, but then we need to count how many over sulfur is into the p block. And starting with aluminum, we count 1, 2, 3, 4, and know that sulfur is the fourth element in the p block of the third row of the periodic table, so we're ending our electron configuration with 3p4. So now we have our electron configuration, and we needed to determine the types of orbitals that are holding sulfur's electrons. So we can do this just by looking back at our electron configuration and noticing that we have s orbitals. So one of our types of orbitals would be the s orbital. And then we have a second type of orbitals, and that is the p-type orbitals. So we have s orbitals and p orbitals in sulfur's electron configuration. Now, if we wanted to determine how many of each type of orbital we have to think of how many orbitals of each type we can have at a given energy level. So we know that we can have one s-type orbital at each energy level, and that one orbital can hold 2 electrons. So we have 1, 2, 3 total s orbitals. And then we know that we can have 3 p orbitals at each energy level. So if we look here, we have p6. Those 3 p orbitals are holding 6 electrons. So we have 3 p orbitals here, and then we have another 3 orbitals here. Even though they are not full, we still know that we have those 3 orbitals, and those 4 electrons will go 1 in each orbital, and then the 4th electron would go in the first p orbital, like that. So we have a total of 6 p-type orbitals in this electron configuration. So moving on to the next box in your table here, it asks you to find the valence energy level. And if you remember, the valence level is the outermost energy shell of that element, which here, in our electron configuration, our energy levels are represented by, by the numbers in front of the types of orbitals. So energy levels 3, 2, and 1 all have electrons in them, and our highest energy level, or our valence level, is energy level 3. And we see these 3's in front of both the S-type orbitals and the P-type orbitals. So our valence energy level is 3. But to figure out our valence shell electron configuration, all that means is to take the parts of the electron configuration that are at energy level 3 and to list that part together. So our valence shell configuration would just be this part that I've kind of boxed around right here. It would be 3s2, 3p4. And that would be just our valence shell configuration. So we're ignoring the other shells that are on the inside of all the electron shells, and we are just taking that very outermost shell. And then going to the next column, if we want to determine the number of valence electrons, all we need to do now is take that valence electron configuration that we wrote right here and just add how many electrons that is holding. So here we have 2 in the s orbital and 4 in the p orbital, so our total number of valence electrons is equal to 6. So moving on to the number of electrons gained or lost to achieve an octet. If there are 6 electrons already in our valence shell, we have to think, is that element going to gain 2 more electrons or lose all 6 of those electrons? And remembering back, thinking elements are lazy. They are going to do the easiest thing possible for them to do, and it's a lot easier to gain 2 than it would be to lose all 6 electrons. So this element is going to gain 2 electrons to reach that full octet. And if we gain 2 extra electrons, 2 extra negatives, then that is going to make our charge negative, because we have more negatively charged electrons than we have positively charged protons. So our ion that we formed from sulfur is going to have a charge that's negative and equal to the number of electrons gained, which, as we know, is 2. So our S2- is our ion that is formed by sulfur. And then once we gain those 2 electrons, our element, or now our ion, is going to have a new electron configuration because we now have 2 extra electrons. So sulfur started out with 16 electrons, but then it gained those 2 electrons, so now it has 18 electrons total. So its electron configuration is going to be slightly larger. And to figure out what that's going to be, all we have to do is find sulfur on the periodic table and move over 2 spaces to the right to the element that has 18 electrons already. And we know that sulfur's electron configuration, once it's an ion, is going to be the same as the electron configuration of argon. And so, since argon is a noble gas, its electron configuration, shorthand notation, can just be written as argon in parentheses. Shorthand. So this is sulfur's electron configuration written in the shorthand. So it's ion noble gas notation for sulfur ion is just argon in brackets. And then our last but not least, the thing we have to figure out now is what is the valence energy level of the ion. Since argon gained 2 electrons and now has the same electron configuration as argon, we can just look at what the valence shell for argon is, and if we count down on the periodic table, we note that argon is in the 3rd row, so its valence shell configuration would be 3s2 and then 3p6, so its valence energy level is still energy level 3. Hope this helps, and I will see everybody tomorrow.